Lesson 83, Factoring Special Products. So we've been working on factoring trinomials, and we've had different formulas that we could use to factor. You could factor, we've had formulas where you had a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. Then we've also had where we had a squared minus b squared before, instead of using FOIL. Now here, they're giving us the trinomial. We have to put it back into the special form. And so instead of using this part of the formula, we're going to use this part of the formula as our answer. So here, to determine if the polynomial, we need to determine if the polynomial is a perfect square trinomial. If it is, then we need to factor it. To determine if it's a perfect square trinomial, the first step is to check to see that the first term and the last term are perfect squares. Because this is x squared, I know that x times x is a perfect square. So I know that x squared is a perfect square term, and then 9 is the square root of 9 give me an integer? Yes, it gives me 3. And now if I use this formula up here, your a squared plus your 2ab plus your b squared, can I take, there's a 1 in front of here, can I take the 1 times the 3, because 3 times 3 gives us 9, that gives me 3. Does 3 plus 3 give us 6? Yes, so I know that my trinomial, I can either do it x plus 3 times x plus 3, or as a perfect square trinomial, we know that it would be x plus 3 squared. So yes, this is a perfect square trinomial. The next one, check the first term and the last term. Are they perfect squares? Yes, because 4 is a perfect square, that's 2. Now in the middle, we have a negative 2x. So if I take this, the square root of 4, and I have a positive 2 plus a positive 2 is a positive 4. If I took it as a negative 2 plus a negative 2 is a negative 4. This middle term is a negative 2. So just because this term and this term are perfect squares, the middle term does not make sense for it to be a perfect square trinomial. So no, we can't solve this one. We're not able to find two numbers you can multiply to get 4 and add them together to get negative 2. So that is not a perfect square trinomial. Next one, determine if this polynomial is a perfect square. If yes, then factor. Well, I know 36x squared is 6x, so the square root of 36x squared is 6x. The square root of 16 is 4. Now, is there two numbers I can multiply to get 48x? Well, if I use this form, I would have to use this one right here because of the minus sign, and there you have a minus sign here. If I have this as my binomial, and I have 6x minus 4, if I plug it into this formula, this would be my a, this is my b. I would have 6x squared minus 2 times 6x times 4 plus b squared, which is 4 squared. Here's your 36x squared. 2 times 6 is 12. 12 times 4 is 48x squared. And then 4 squared is 16. So our answer, yes, this is a perfect square trinomial. Our factored binomial would be 6x minus 4, and this would be squared. The next one, we got 3g squared plus 9g plus 9. I know this is not a perfect square trinomial because 3 is not a perfect square. So therefore I can stop right there, and I would not have to factor that one because it's not a perfect square trinomial. Look at an application problem here. A cellular phone tower's signal covers a circular area with a radius r in miles. The strength of the signal is increased and now covers an area of pi r squared plus 10 pi r plus 25 pi square miles. By how much did the radius of the coverage area increase? So to start off for this one, we have our pi r squared plus 10 pi r plus 25 pi. I can take out pi out, and that leaves me with r squared plus 10r plus 25. And I need to factor this trinomial here. And I know r squared, square root of r squared is r, plus I know the square root of 25 is 5. And I know I can have, in order to get this 10r here, I know that's r plus 5 again, because here's r times r is r squared. R times 5 is 5r. 5 times r is 5r, so that gives 5 plus 5r plus 5r is 10r, and 5 times 5 is 25. And then we have our pi out here, so we would have pi times r plus 5 squared. So that's the area of the new radius with the new radius. So the old radius was r. The new radius is r plus 5. So how much did it increase? To go from r to r plus 5, it increased by 5 miles. Next one, factoring with a difference of two squares. This one, you have a perfect square in the first part, you have a perfect square in the second, and you're subtracting it. So this is a binomial, and when you write it, when you factor that out, you end up with two binomials that have opposite signs. So an example, you have x squared minus 49. X squared is a perfect square, that's an x times an x. 49 is a perfect square, that's a 7 times a 7. In order to get a subtraction sign in between, one's got to be positive, one's got to be negative. So the easiest way to determine this, find the square root of both parts. And if you can find the square root of both parts with integers, then you know it's a difference of two squares. So the square root of 4 is 2, the square root of x squared is x. Square root of 25 is 5, so minus 5. And then I know that 2x plus 5 would be our answer. So yes, this is a difference of two squares. If I use FOIL, the middle term cancels off. 2x squared is 4x squared. 5 squared is 25. The next side, find the square root of both sides here. I'm left with 3m squared, because m squared times m squared is m to the fourth. 3 times 3 is 9. So now I have minus square root of 16 is 4. The square root of n to the sixth is n to the third. Then I know 3m squared here plus 4n n to the third. Because I know a negative 4 times a positive 4 gives me a negative 16. N cubed times n cubed gives me n to the sixth. So yes, this is a difference of two squares. So you're just looking to see if you have a perfect square at the beginning, perfect square at the end. If it is, then you can write it as a difference of two squares using this formula. Next one, determine if the binomial is a difference of two squares. X squared is, right, 8 is not a perfect square, so no, this is not a difference of two squares. This next one, anytime you have your variable at the end, I would rewrite this to be z to the 8th minus 64, because that's really what this is saying. You have a positive, if I rewrite the terms, rearrange it, positive z to the 8th divided minus 64, z to the 8th, the square root of z to the 8th is z to the 4th. Square root of 64 is 8, so minus 8. And I can have z to the 4th plus 8. Z to the 4th times z to the 4th is z to the 8th. Negative 8 times 8 gives me a negative 64. So yes, this is a difference of two squares. And our last question, Jacob is designing a square border around a square pond. The area of the pond is 225 square feet. Use the difference of two squares to write an expression that represents the area of the border. So they said the area of the pond is 225 square feet. So this is 225. The border, we need to square this since it's a square. We would have to square 2f, square it, and a difference of two squares, and then I take this minus 225. So this is 4f squared minus 225 square feet. So now we can write this as our binomials. So I know I can find the square root of 4f squared, which would be 2f on both the top and in each binomial. One's minus, one's a plus. The square root of 225 is 15. So this would be our expression to find the area that represents the border. 2f minus 15 times 2f plus 15. That is our lesson today on perfect square trinomials and difference of two squares, all of which are special products.